Today we are going to learn about rotational of rigid body. Okay, we start with rotational kinematics. A rigid object is an object with a definite shape that doesn't change. The motion involves a translational motion and rotational motion about its center of mass. The points on a rigid object move on a circular path. Before we go further about translational and rotational motion, we might begin to discuss about a certain angular quantities, which is, first we have angular displacement. Angular displacement is the angle delta theta swept out by a line passing through any points on the body and intersecting the axis of rotation perpendicularly. The SI unit of angular displacement is radian, and the other unit are revolution, which is 1 revolution is equal to 2 pi radian. Degrees, 360 degrees equal to 2 pi radian. Sign convention. The sign will be negative if the rotational motion is clockwise, and it will be positive if the rotational motion is anti-clockwise. Average angular velocity. The average angular velocity is defined as the angular displacement delta theta divided by the some time period delta t during which the displacement occurs. It is denoted by the formula omega equal to theta f minus theta I over Tf minus Ti. The SI unit of average angular velocity is radian per second, and sometimes we might encounter with another two units. They are revolution per second or RPS. 1 RPS equal to 2 pi radian per second, and the last one is revolution per minute or RPM. 1 RPM equal to 2 pi over 60 radian per second. Average angular acceleration. The average angular acceleration is defined as the change in angular velocity delta omega divided by the elapsed time delta t. It is represented by the formula alpha bar equal to delta omega divided by delta t. The unit of average angular acceleration is radian per second square. For the sign convention, it will be positive if the angular velocity is increasing, but it will be negative if the angular velocity is decreasing. Instantaneous angular velocity. The instantaneous angular velocity, omega, is the angular velocity that exists at any given instant or at any given point. The formula of instantaneous angular velocity is given by omega equal to d theta over dt. It refers to angular velocity at point A or angular velocity at time t. Instantaneous angular acceleration. The instantaneous angular acceleration, alpha, is the angular acceleration at a given instant. The formula of instantaneous angular acceleration is alpha equal to delta omega over delta t or d omega over dt. It refers to angular acceleration at point A or angular acceleration at time t. The value of instantaneous angular acceleration are same for all the points. We continue with relation between linear and rotational motion. Table 1. The table shows the quantity for both linear and rotational motion, while table 2 shows the comparison of the formula for linear and rotational motion. Do you know how do we initiate the rotational motion? Okay, we can do this by generating something that we call a torque. We go to the definition. Torque is a turning action on a body about a rotation exists due to a force. Formula of torque: tau equal to R times F, or tau equal to F R sin theta equal to Fd. Torque is vector quantity. The unit of torque is Newton meter. We proceed with 8.3, rotational dynamics. Moment inertia of a uniform rigid body. Definition: the property of an object to resist changes in its rotational state of motion. The general equation of moment inertia: I equal to mr square. M stands for mass and R stands for radius. Unit kgm square. Okay, the formula of moment inertia is depends on the shape and the types of object. Torque of a uniform rigid body. Rigid body is made up of n particles. Thus, torque on the rigid body is given by torque equal to summation of mi r I square alpha. I is equal to 1 to n. Torque equal to I alpha. And the last but not least is 8.4, conservation of angular momentum. Conservation of angular momentum happen if there is no external torque X on a system. The total angular momentum is remain constant. I omega equal to constant, and the summation of L initial must be equal to the summation of L final.